Hi everyone, welcome back to my YouTube channel. In today's video, we are gonna go through chapter number 3, which is storage and retrieval. For me, this was the most interesting chapter. The reason was this chapter has most of the data structures mentioned, and that become very keen interest for me. So when I say data structure, across this book, there are around 8 to 10 data structure which author has mentioned, and out of those 8 to 10 maximum got mentioned in this chapter. So what I'm gonna do is, because it's my interest area, I'm gonna make few more videos to discuss those data structures. For someone who is interested, they can follow, otherwise it's fine, you can just skip those videos. Now in this chapter, as the name says, storage and retrieval, in the last chapter we went through the databases, that how you should structure your data, and basis of that what are the databases we have and the query language. But here we are going one more layer under our database, and we are talking about the storage engine and retrieval. Now why this is important? So the focus of this chapter is exactly this, that why we are talking about storage engine, why it is crucial, and what are the different engines and use cases. So a few of you might feel that I know how to structure data, I can take the best decision that which database to use, but this chapter actually highlight another important thing, that as an architect, engineer, or a developer, you should understand that every database has a storage engine and what is their design philosophy, how they actually store the data, retrieve the data, update the data. Now why these are important? Because in the starting, if you remember, in chapter 1 and 2, I explained that the performance of your application also does matter, that how your data is getting accessed, and this is why it is important. So how a particular storage engine is gonna work, that is gonna help you to take the better decision for your application. Again, the goal here is to understand how every storage engine store and retrieve the information, and what are the use cases, which database actually follow that particular design philosophy. Okay, so this is a focus. Now before we move ahead, there are a few contexts I want to set. So this particular section actually come at the last of this chapter, OLTP versus OLAP, but I wanted to put it first because this is important to know. Now when you divide the kind of processing you are gonna do on your data, you can divide it into OLTP, OLAP, or basically you can divide your databases into OLTP versus OLAP. Now what it is? So the full form is online transaction processing, and A stands for analytics. So before I go to transaction, let's talk about the analytic first. Analytic, as it says, it does the analytic process. So whenever you have a large chunk of data, millions, billions, and on that you wanted to do analytics, so that actually falls into OLAP. And your day-to-day everything work, like getting the data and non-analytic work which you are doing, it falls into OLTP. So it's transaction. Now why it is important and why I'm telling you it as a first thing, the reason is because whenever you are now from now onwards, whenever we are looking at a application or problem, the first thing we can ask ourselves is the application is OLTP or OLAP. Am I gonna do any analytic work? If not, then I will go to the OLTP. So that's why it's important to know. Now there is a very interesting history given that why it is transaction. So when you talk to engineers in backend, or when you read about system design or databases, you will see that every one whole end-to-end user journey or event is known as transaction. So like for example, if I am submitting, I am doing e-commerce purchase, so that's a transaction. If I am saving, withdrawing the money from my bank, and I am withdrawing and then my balance should reflect, that is a transaction. So there's an interesting history behind that why it is called transaction, because many years ago this record system was used primarily by the accountants for accounting purpose. So in that accountant firms or accounting world, these are known as the transaction. So that's why this word got picked, and now we are using it for everything in our world. So for me it was a very interesting thing to know. So yeah, it was good. So now let's move forward. So now we know OLTP, OLAP. Now if you think about a database, uh, in a very simple way, what all you need to do is you will be having a file. You will have two functions which will be doing, one would be doing saving the value, which will have a key and a value, and then another function which will get that value by providing that key. So you will have a file. In that file, whenever you are running db set with key and value, that value will go there with the key, and when you are doing get with key, you will get the value. This is the simplest way you can think about a storage system or a database. So now what is this file? It is just a key value in a file, and whenever you are adding new values, what will happen then? The value will be append at the last. And what this is known as the log based. So imagine if you have key 1 and some value abc, then you want to update that value, so you will do key 1 value 567, so that 1 2 3 value is still there, and 567 will get appended at the end, which will be the latest one. And this is where exactly the problem starts coming. So when you start saving your data like this as a log file and appending, you will end up with the multiple values of one key. So when you wanted to retrieve that information, what will happen is you have to go through all the multiple records. So in the performance way, this is a bad read. But in the write, because what is happening, we are just providing a key and a value. So, and it will get a pen. It is not gonna search anything. It is not gonna update anything. So this is the fastest way. So reads are fast in log based, and writes are fast in log based, but the read are the expensive one. Now why we are talking about, I'm gonna explain you this further. Then the author reached to solve this problem, it introduced index. So it is another data structure. So what the idea is that we will have a metadata which will have index, and which is like a signpost. It will tell you that where exactly what value is, and this metadata is based on the original data we have. But now what is going to happen is, every time we need to write anything in our file, we need to also update that metadata. So you think like you have a file where you have a like your table of content of a book. Every time you are doing a new entry or updating something, you need to go and update that table of content of your book. Similarly like this. So now what is happening is writes are expensive, because every time we have to write, and this is the reason the database doesn't provide the index by default. So what we were doing is we were creating an index for every record, so that whenever some query will come, we will go to that particular file, look at the index and return or update. But because this is an expensive write, this is the reason database doesn't provide the index by default. It leaves on the developer to decide the index, that which should be the index, which value should be the index based on the access patterns. So that's why in your relational one, you pick most of the DBs you will pick. There you will have to decide your own index, primary key, secondary key. So this is about index and DB. Now what are the type of storage engines? So the one I explained you with db set and db get, like in a file you are appending, that is actually known as the log base. So we can divide our storage engines into two parts. The first is log based and second is page based. So log based means you are just doing the appending, new writes goes at the end, writes are fast, reads are slow, I just explained. And this is very good in recovering. Now why it is good for recovering? Because you are having the record of all the things happened. So imagine if I am doing some work and this file get crashed, what will happen? I can go back and before that crash happen, I can recover all my record, recreate this file. Now take an example. For example, you have a website where you are maintaining the log based, you are using log based storage engine. So basically for your comment section, now you have around 30,000 or 20,000 comments, and suddenly your this db got crashed. But now what will happen is, because it's a log based, you can go to your backups, and before it got crashed, those 20,000 and 30,000, you can retrieve those and keep it here. So at least you will have something, so it's a good for recovery. Now which databases actually use it? So level db cassandra uses this log based storage engine. So now as an engineer, developer, architect, now when you are thinking about which database to use, storage engines to use, you can actually start thinking like this: is it a OLTP? It's a OLAP. Okay, it's a OLTP. Okay, what we are looking for? Are we looking for fast read? Are we looking for good recovery? Okay, are we fine with append only? Okay, then we can think about level db versus cassandra. So this is how you do it. But it doesn't mean that this is a very good this is a like the best of the best. As I told you in the start, everything is a trade-off. You should understand the reads are very slow here. Now why the reads are slow, what are the ways to tackle that, all that, for that we have three data structure got introduced here: mem table, lsm, ss table, which is sorted string table. So this is interesting one. I'm gonna talk in detail in a separate video, as I told you that this is something I have a lot of interest. And while reading this chapter, I got interest. So I'm gonna make a detailed video about this, apparently high level, because here what is happening is that your reads are slow because of because you have to duplicate value. Then what else we can do? So in these three comes, and also the size does matter, because if you will have one file and you just keep appending, the file size will increase. There are so many duplicate. How you can optimize that is also discussed in this. So I will make a separate video in detail. Now second one is page based storage engine. The data is split into fixed size blocks or pages like 4 KB, and where in the log base we were appending the values instead of replacing or updating. In page based, what we do is we update the key or the value in place. So for example, if I have key 3 and value abc, if I do a new update for key 3 567 or something, instead of appending, it will go to that particular key and update the value. So in place it is replacing. And the database, it uses b trees. Now b trees are actually they are the structure and the balanced one. So in this particular page based storage engine, this b tree actually helps in doing the indexing and in place replacement. So so databases, we use b trees, and b trees, because they are structured and balanced, they actually help in maintaining the index and doing these updates. So it is very good for random reads. So where in log base the reads were very expensive, but here it is very good. Why? Because in this we are gonna index everything. How we are gonna index? Because we are splitting them into pages. Every page is actually gonna store in b trees as their node. Now b trees is already balanced, so indexing it is already well indexed. So doing any random reads is good. Now in place updates can be complex under high write load. Now this is a trade-off. What it means is that if you will keep updating the same value again and again, obviously you are doing a lot of input output work. So there is one trade-off. Concurrency can be a challenge. If multiple people are gonna edit or update the same page or something, that's an issue. You have to introduce the lock and different strategies to do that. So in place methods introduce these kind of problems. Example, you have which databases use this this storage engine is MySQL and Postgres. Now, so this is the overall pitch summary of this chapter. Just remember, you have OLTP, OLAP. Why index is not provided by default? This is a good thing to remember. And your storage engines are two type: but there are two type of storage engines, log based and page based. They are trade-off, please remember that. Now if you have seen, we are talking about B trees here, and I already told you that I'm gonna make a separate video on the data structure mentioned in this book, and especially in this chapter. So wait for that. If you wanted to go more in detail, please do watch that video. So thank you very much for watching this video. I hope you are reading the DDAI book, and just let me know in the comments if you find something which I missed or something interesting. I will love to add in my notes. Thank you so much. Take care. Bye.